Good morning, Your Honour. I'm Beck. Thank you for the indulgence of being excused.
I'm back to you, Your Honour.
Your Honour, we're having trouble hearing you in court too.
Because that's facing that way. Is that better?
Yes, thank you.
Is that Mr. Lloyd here? I
Yes, sure.
can't see because of the insert. And Mr. Baroni.
Yes, Your Honour.
Good morning. All right. Yes, Mr. Castleton.
Thank you, Your Honour. I call Dr. Simon Heemstra.
Silence, please. Do you solemnly and sincerely declare from the evidence that you shall give me the truth, the whole truth, nothing but the truth? So please say I do.
I do.
Take a seat, thank you.
Doctor, would you please state your full name
Simon Peter Heemstra,
and your present occupation?
Manager Predictive Services, New South Wales Rural Fire Service.
And you've prepared a report in relation to the Tathra or Reedy Swamp fire dated the 31st of August 2018.
I did.
Do you have a copy of that with you?
Yes, in front of me.
Your Honour, it's found in volume 4, tab 23, commencing at page 1539. Doctor, could you just set out briefly your experience, training and qualifications in relation to fire behaviour and fire prediction?
I have a couple of decades experience in fire behaviour and fire prediction. My PhD was looking at fire behaviour. I've worked for the Rural Fire Service I've been a volunteer since 1994. I've worked as a staff member since for the last 18 years. I've been responsible for establishing the fire predictive unit within the Rural Fire Service. I also have led and chaired the National Predictive Services Group through the Australian Fire Authorities Council. I'm the lead end user for the fire behaviour research stream within the Bushfire and Natural Hazards CRC, and I've been actively involved in a lot of research in the fire behaviour area.
Now, in terms of the science of fire prediction, is the end result only as good as the assumptions upon which the fire behaviour analyst relies upon? Correct.
We have a series of fire spread models that have been developed in Australia under experimental conditions. We can extrapolate and use those for wildfire scenarios. And the training that our fire behaviour analysts undertake is how to apply those models, how to use the assumptions within those models, how to modify the models based on their experience and also observations from fire behaviour, and to come up with their best estimate or their best prediction for that fire. There's a range of products that they produce.
I was going to come to that later, but we might as well deal with it now. In terms of some of those fire models, for the southeastern region of New South Wales, primarily the Bega Valley area, given the predominance of sort of dry sclerophyll fire vegetation, is there a particular model that you would see as being more effective when one comes to do that fire behaviour analysis?
Yes. For forested areas within Australia, which also includes the southeast, there are two forest fire spread models that we use. The MacArthur fire spread model, and there's a prescribed burning and a wildfire version of that MacArthur model, and that was developed in the 1960s. And then there's also the Vesta model that's been developed through CSIRO, and that has some application as well in forested areas that we've been applying.
Has the MacArthur fire model been revised or updated since the 60s when it was first introduced?
There's been various applications to improve the way that model works, and particularly some of the assumptions as to how you will spread a fire under different vegetation types. And there's been some excellent work done by Dr. Kevin Tolhurst as far as how we apply that model, and that's built into the fire behaviour analysis training that our FBANs will use for fire spread predictions.
And as at 2018, was it the MacArthur MK5 model that was
Mark 5 MacArthur, yeah.
Mark 5? Yes. And in terms of its limitations, and of course every model does have limitations, as you would accept, what were the main limitations in relation to applying the MacArthur Mark 5 model to fire behaviour analysis?
In the context of this fire?
Yes, please.
So the MacArthur model is looking at a traditional sort of spread or line of fire, and particularly it can significantly underestimate fire behaviour under more eruptive fire conditions or extreme fire behaviour. And there's a range of phenomena that we look at that can cause those sort of big fire runs. And in the case of this fire, there was a mass spotting event, and that would exceed what MacArthur would generally be able to predict in those sort of situations. You could get vortice-driven lateral spread, pyroconvective fire behaviour like that. There are other phenomena that can occur to make fires erupt and spread quite quickly. But in this case, it was more of a mass spotting event that we saw that would definitely be exceeding the sort of things MacArthur would do.
When you use the term mass body event, what do you...
Spotting.
Oh, mass spotting event.
Spotting, yes.
My apologies.
Yes, mass spotting.
A term I hadn't heard before.
So mass spotting is where you end up with an enormous amount of embers being produced and being thrown in front of the fire front, and those embers successfully igniting the landscape in front of the fire. And so rather than having a progressing fire line, you end up with a landscape on fire. And it's one of the eruptive sort of fire behaviour phenomenon that we can see.
And I think you said that when you have an event like that mass spotting occurring, the MacArthur Mark 5 model will underpredict its spread, I take it.
It can. The MacArthur model incorporates spotting. It's one of the parameters that you can calculate with the formula as far as a spotting distance. But spotting is a stochastic nature. There are embers and they'll be thrown in front of the fire. Which ember is actually going to land and be successful is almost impossible to tell. So it's a probabilistic sort of understanding. In this situation, if you get a lot of dense burning material, like a lot of heavier dense material and an enormous amount of it, you can end up with this mass spotting sort of event that we saw with this fire.
What, if anything, can a fire behaviour analyst do when they're faced with potentially a mass spotting event in terms of fire prediction?
So I'm just gathering my thoughts to think how I can summarise it. The first thing is, I suppose this is the difference between the science and the art of being a fire behaviour analyst, and it's the value of having fire behaviour analysts within incident management teams. It's the conversation that they will have with the incident management team in explaining these sort of phenomena. Sometimes it's difficult, and particularly for this fire, it would have been quite difficult to know beforehand that that's something that was going to occur, and I may get to explain that later on this morning. But if you start seeing those sort of events, that's the dialogue you can have, and it depends, particularly for the fire behaviour analyst. It depends on the time that it takes to do a prediction, and also how much time you have before impact as to how valuable, whether it's a conversation or whether it's something you're drawing on a map.
Is one of the integers that the fire behaviour analyst would be looking for is information or intelligence coming from the fireground, from personnel that are in and around perhaps the head of the fire to see how it's behaving?
Definitely. Often if you've got fire behaviour analysts who have local understanding, they're at an advantage because they'll understand that landscape better. But generally, there's an iterative process of doing fire spread prediction. The first prediction is often will have a lot of errors in assumptions, and then as you see the fire progressing, you'll test those assumptions, and in subsequent predictions you'll be able to modify your prediction based on observations of how that fire is behaving in that vegetation under those weather conditions.
Now, you've identified some of the limitations in relation to the MacArthur Mark V model, particularly in respect of mass spotting events. Are there similar limitations in relation to the Vesta model, which is the other model that you referred to earlier in your evidence?
There are different limitations, and I suppose spotting is incorporated within the Vesta model, and it's probably more fixed in how it behaves. There's less opportunity to modify the model for the fire behaviour analyst. Generally, Vesta will tend to show a faster rate of spread, but the other probably limitation with Vesta is the input values that we put in as far as the fuel types. The MacArthur model, you put a tonnes per hectare of fuels, whereas for the Vesta model, it's based on overall fuel hazard scores. And our understanding and mapping of those is still not great, and particularly overall fuel hazard scores. We're looking at building better models to predict them in a quantitative sense, but generally it's based on subjective observation, which is often very accurate after event, but in a predictive sense can be very challenging as far as where you're at. The other thing is that the Vesta model is very sensitive to some of the fuel type inputs that you put into it, and so but if there's a small error in the fuel input, it could have a massive error in the prediction of where that fire line boundaries are going to be.
Again, given those sort of general limitations, how does a fire behaviour analyst within an IMT determine which of the various models that are at his or her disposal when coming to do their fire spread prediction?
A lot would be based on experience. We do have a fire behaviour analyst handbook, which goes through under which scenarios and which models should fire behaviour analysts be using. And I believe Stuart Matthews submitted that as part of his evidence to the court, the fire behaviour analyst handbook.
He has.
And under that, we will describe under which vegetation types are the most appropriate that we suggest that they use, but then ultimately it will be up to the fire behaviour analyst as far as what they believe for that situation would be the best model.
And that could be because of local knowledge in relation to topography?
And
local knowledge in relation to fuel load levels?
That's correct.
And what they're receiving from the fire ground?
Yes, and they will also, our fire behaviour analysts will also consult with the ones in the incident management teams with head office, and we may have, through that support, be giving advice as to which model they should be using in what situation. But generally, for forested landscapes, the go-to model we use is the MacArthur Mark V.
So given that answer, you have no difficulty with the MacArthur Mark V being the relevant tool that was used by Mr. Philp when he came to do his fire behaviour.
Yeah, I would be very happy that's the model he chose, yeah.
Now, I just wonder if I may take you into your statement, and if I can just bring up, please, Annexure 9, which is 1686 onto the screen. Do you have that handy, Dr. Heemstra? Now,
is that page 1686?
That's 1686 of the brief of evidence. It's
Yes, it is.
it's for your statement. Do you have that?
I've got my statement in front of me. So which page number?
1686. It's Annexure 9 to your statement, Doctor.
Oh, yes.
Now, I just wanted you to explain for the uninitiated the impact or the effect that the weather had on the 18th of March in relation to this particular fire's behaviour. And if you could particularly focus firstly on the time period at 10:30 and then also at 12:30, which is about the time the evidence seems to suggest that the fire had commenced or shortly after, so shortly before that time. Now, there's a number of integers that are relevant to fire behaviour. Temperature, do we see there that between 10:30 and 12:30 the temperature's increased?
Yes, there was a significant jump in temperature over that time.
And that's a relatively short period of time for an increase of perhaps 4.5 degrees or thereabouts, or maybe more, nearly 5. Now, relative humidity, how does humidity play a part in relation to fire behaviour?
So humidity has an effect on the fuels by reducing the amount of moisture in the fuel. And for fire to spread and ignite biomass, it needs to remove the moisture from that fuel before it can volatilise the biomass. And so the lower the humidity, the more flammable the vegetation becomes.
And how would you describe that decrease in that sort of 2-hour period from 32 relative humidity in percentage terms to 18?
So that's a very significant drop in humidity. One of the other factors, that drop started to occur around 10:30 and probably it had hit the 20s by 11 o'clock. The other thing that occurs within fuels is that if the air becomes dry, there's a lag within the time that the fuel's dry. And if the air becomes moist, there's also a lag within which the fuels absorb that moisture as well. And so,
Is that about a 2-hour period on average, that lag?
yeah, depending, as a rule of thumb, yes, 2 to 3 hours, you can see that sort of lag occurring. And particularly at times when you're seeing a very sharp change in humidity, it's where we need to factor in those sort of changes. And so, yeah. And I suppose this is a feature of the MacArthur system. The raw fire danger index, maybe you're going to get to that in a minute, is calculated based on the instantaneous observations. Yes. But in reality, and what our fire behaviour analysts will do, and this is when they have time to do a more fulsome analysis of a fire, not during a rapid appreciation, but they will adjust those humidities based on those lags. And so it will take a while for a fire danger to ramp up, but it will also hold higher later on in the day when humidity drops.
And just in terms of 18, that is considered a low relative humidity?
Yes, that's quite. I mean, obviously, humidities can go down into well below 10, which we saw in this last fire season very often, but particularly for that part of the landscape in the South Coast, that is a low humidity.
Now, in terms of wind direction, what significance, if any, do we see in the wind direction changing from 10 degrees at 10:30 to 320, which is sort of a northwesterly wind, at about 12:30? Yeah,
so I suppose that there's also a correlation with wind direction and wind speed. And so you're seeing lighter variable, probably southerlies to almost a northerly. So there's a big change around in wind speed early in the morning.
That's sort of at 10 o'clock.
Yes, and then well,
you've got a southerly. It looks like you've got a southerly at 8:30.
8:30, yeah. But they're very light wind speeds, and the thing is also that this reading is 1 per hour, and a lot can happen within an hour. So winds can shift around and move, and it probably what that direction doesn't show you is how much variability there is in wind direction over that time. But particularly because you're seeing the winds are so light, you would expect them to be quite variable over that period, and they're switching all the way from southerly to northerlies. But then by the time we hit midday, the wind speed has significantly increased, and there's very strong nor'westerlies and then moving westerly later on in the day.
And in terms of fire behaviour, what's a northwesterly wind like for fire behaviour?
In that part of the landscape, they're winds that have been coming over the land, and so they're generally going to be drier winds that are coming over land, and also warmer winds that we'll be getting.
Are they considered a bad wind for for fire?
In the southeast of New South Wales, yes. And westerly and northwesterly would be the winds that will be bringing drier, hotter air over the land.
Now, just in terms of wind speed, you've mentioned some aspects of that, but we must not forget the wind gusts were hitting, certainly by 12:30, upwards of 70 kilometres per hour. That's a significant wind speed, is it not?
Yeah, so when you see quite a large difference between mean wind speed and the peak wind speeds or gusts, you're seeing that you're getting quite erratic sort of winds, which can give you a lot of turbulence and bursts onto the fire ground.
And does that, in terms of spotting, is that conducive to spotting those types of winds?
Yes, definitely. Gustiness is going to cause is a feature of more turbulence, and so you're going to have greater ability for embers to be entrained into higher layers in the air and transport further with that gustiness.
Does that also depend on convection as well in relation to spotting generally?
Yes. So, fires generate heat and heat rises, and so, and particularly hot fires are going to have a convective column, and so that's going to be entraining embers into that column as well. That's going to be intersecting with the winds that are coming over through the landscape, and so the embers are drawn up and then transported further.
And as if, for example, if the fire was to hit the top of a peak or a ridge, is that also going to aid in potentially significant spotting?
Yeah, it's a mechanical effect that if a fire's running up a hill, it can act as a ramp, and that ramp can then also throw those embers further up into the atmosphere with a fire. With prevailing winds hitting that hill or mountain range, it will then also continue to project those embers further up due to their mass higher into the air.
Now, FFDI, is that Forest Fire Danger Index?
Yes.
Now, again, if one goes to 1030, it's sitting at 19. On the scale, what would that rating be?
So that's a high.
And then at 1230, it's a touch below 50.
Yes.
Now, what's the rating just below 50?
Very high.
And over 50 is extreme, correct? Severe.
Severe, yes.
And we see that it goes into severe FFDI at 1 o'clock.
Yes.
Now, at this time of year, this is late in the bushfire season, is it not? We're sort of 18 March. How would you describe those FFDIs around 49 to 55?
Extraordinary. So for that part of the landscape at that time of year, some work we'd been in discussion with the Bureau of Meteorology. There had only been a handful of times where fire danger had become that high in the last 50 years, and at that time of year there had never been a fire danger that high for that period.
So that was a record at that point in time?
Yes.
Was it surpassed in the more recent bushfires that occurred sort of December, January of this most recent season?
For the South Coast, I'm not sure. I'd have to. I'm not aware for that. There definitely were a lot of records broken over this last fire season, but for that part of the state, I'm not sure of that one.
Has there been some recent research by meteorologists in relation to some of the effects that may have occurred in relation to the Tathra bushfire, in relation to weather behaviour?
Yes. So work by the Bureau of Meteorology and still in pre-publication has done a high-resolution reconstruction of the weather for that landscape. For the forecast weather under the graphical forecast data that the Bureau produces is based on a 6 kilometre grid resolution and at hourly time steps. and so there's a lot can happen in between those gaps or variability in the landscape. This research, what they did is they reconstructed the weather based on a 400 metre and then a 100 metre grid cell, so many times higher resolution, and also looking at 1 minute data. And so you get to analyse the weather and look at a lot of fine scale and fine resolution weather effects.
And what was the general conclusion as a result of that high resolution analysis that has recently been undertaken?
So what that work found was that there were some fine scale weather phenomena that occurred with this fire that definitely would have assisted with the mass spotting event that occurred. So there are weather phenomena called mountain waves and boundary rolls, and so in effect, what a mountain wave can do is that with the prevailing winds coming over the dividing range, yes, it sets up the mass of air comes over the range and then drops down, and so it accesses a lot more of the weather aloft, and particularly where you're looking at dry air aloft and also very windy, that those mountain waves can help draw that dry windy air down, and that's particularly where we're observing that strong gustiness. That would explain a lot of that strong gustiness that we saw with this fire. The boundary rolls are basically phenomena that get set up where you get a lot of air that can be lifted and also brought down in the atmosphere, and this is again due to this turbulence due to the topography.
So they're interrelated, the two concepts.
Yes, and I mean particularly for the issue we were looking at with spotting, there were a lot of things assisting mass spotting with this event. So there was the effect of the ramp with that uphill run that the fire had, but there was also these boundary rolls were causing a lot of updrafts, and so that would also help entrain embers and bring them up, help them more embers and into the atmosphere and also transport them further. And
whether it's the MacArthur Mark V model or the Vesta model, I take it they just wouldn't be able to factor in these notions of mountain waves and boundary layer rolls.
No, they're definitely outside the experimental conditions under which they undertook these, and for these models we extrapolate, and that they occurred under more benign conditions and we extrapolate into extreme, and so those sort of phenomena. It's a thing if you have time with a larger fire, and I mean particularly that's the challenge with this fire. It was all happened so quickly. It's something that you just. Some of them you just can't get the prediction on the page quick enough because in a few hours this fire had done what it was going to do. And
I'll come to that notion of how rapid the fire was in a moment. In terms of predicting spotting distances, does the MacArthur Mark V model have a set distance for spotting in terms of its kilometres or not?
It's not a set distance. The model produces a spotting distance, and so that varies.
Does it cap out? Does it have an outer limit that it doesn't take you beyond whatever particular number it may be?
Hypothetically, it continues as far as if you keep putting more wind speed and hotter temperatures and lower humidities, the spotting distance will keep getting further. So there's not a limit to the spotting, but probably what it misses is that it doesn't incorporate some of these other effects that can contribute to spotting. It's based on spotting with a traditional fire line of spread, and based on spotting with a specific vegetation type. One of the things the fire behaviour analysts would need to think about is how much embers might I have in different vegetation types, and so some vegetation types don't produce many embers, and so although the model would say a long distance spotting, it's not very far. But other things, if you've got ribbon bark and particularly the wet sclerophyll forests, produce a lot of material that produces embers that are more conducive to long range spotting, and so then you would be in the model, if you're getting a fire line spread, you'd be assuming the worst case of far as spotting or even further.
And in terms of distances, what would be the sort of the worst case?
So for the model, we'd be looking at things like 8 or 9 kilometres under bad days, but I mean we've been seeing things like 30 kilometres in some of our recent fires.
Do you know, given your analysis of this fire since March 2018, what the spotting distance was?
We were seeing it was 8 to 9 kilometre spotting distance with this fire. I think the models were forecasting somewhere around 3 or 4 kilometres.
Well, that's where I was coming to. When one looks at certainly the situation reports in that critical time frame, say between 1 and 5 or thereabouts, was it 4 kilometres, I think?
Yes.
And how do you explain that when in truth it may have been upwards of 8 or 9?
And that would have been as a result of the other mechanisms we spoke about earlier that is outside the scope of the models that we have, and so those sort of phenomenon would help you massively exceed what the models are predicting.
Now, could I ask you please to turn to page 1689, which is annexure 11. Now, I just want to ask you some questions, Dr. Heemstra, about just fire development. Now, if you assume that this photograph was taken at about 12:29 p.m, just looking at that photograph, given your expertise, what do you see in relation to fire development in that photograph?
So it's in the initial stages, it's white smoke, so the fire is building in heat. Particularly looking at the way that the smoke column is lying quite low into the landscape, you would say that there's quite strong winds pushing fanning that fire, and also appears to be a lot denser smoke in that first little bit, and you see the wispy smoke off to the side. So you'd be assuming that the fire behaviour is building in that image.
Would it have taken hold, do you think, by this stage? Hard to say.
With the likely, but it's hard to say with scale and distance, and particularly with the forecast weather, you'd be expecting a challenging fire. And the other thing is also because it's running uphill, the fire is going to build very quickly. With the wind behind it and also running uphill, the two things are working together in this fire.
Now, if you turn to the next page, I don't know whether you can answer this question, but if you look at the first photograph, there's two, the top one. Do you know what time that was taken or not?
No, I'm not sure. It is later on, obviously, the fire has grown.
It's taken, as I understand it, from the southern side of the Bega River. And again, the bottom photograph, the second of the two, again, do you know what time that may have been taken? And
I'm not sure.
Okay. Well, just looking at the first photograph, it may be that we can work out the time shortly. What do you see in that first photograph in relation to fire development or behaviour?
Smoke is a lot darker, and so fire is building a lot more in intensity. Darker smoke, there's a lot more ash and soot in the fire. The other thing that's interesting is if you look at the second ridge over, it looks like there's a spot fire occurring.
I was going to ask you about that. That's sort of at the top of the rise, slightly to the right.
Yes.
Where there's a column of darker smoke.
So there's another fire initiating on the next ridge by the looks of it.
Yes.
And I suppose the other thing to notice, looking at the photo below, is the gustiness and the amount of choppiness on the water is just demonstrating how windy it is on that day.
Now, do you take anything out of the second photograph in relation to fire intensity?
Again, there's a lot of smoke and it's very dark, so you're expecting there's a lot of fire. And sometimes these things aren't that hard.
You don't need a PhD for that one?
No. And I think, I mean, probably one of the things with both of these images that I'd like to see if I've got people observing the fire is that it would be better if they'd pull back. I want to see how high is the column, what is the shape of the column. I mean, it's an interesting image of a lot of fire, but unfortunately, it would be better to see an image, particularly, and what we're interested in is how high in the atmosphere is that column penetrating? Is there any instability? There'd be other things that we'd be looking for. In this case, we see a lot of smoke and it's windy and below.
Would you agree, though, that it shows that there's a large fire developing?
Definitely.
Now, the next... I just want to take you to the first line scan, which I think is at 3:42. And before I get to that, I just wanted to ask you a couple of questions about... We've talked about spotting, and it can occur some distance in front of the head fire, and you think, obviously, with the benefit of hindsight, it may have been spotting 8 to 9 kilometres ahead. Given the prevailing weather conditions throughout the first phase of the fire, between sort of 1:30, 2:30, do you agree that there was reasonable prospects that spotting was going to occur across the southern side of the Bega River?
With the models, yeah, there was definitely a potential for smoke and embers with that sort of wind speed.
And that's, gusting between 50 and 70 kilometres per hour in that sort of northwesterly, or did shift slightly, I think to west-northwest.
I'd just like to clarify, it's always, with the benefit of hindsight, yes. In a predictive sense, it would be a stochastic thing that we'd be looking at a potential of a couple of embers. And in the situation of how they probably would have been facing that, saying you would get a mass spotting event like this sort of thing is something that, with hindsight, you can see the high resolution weather and you go, oh yeah, for sure, that sort of thing would happen. But in a predictive sense, you'd be looking at the models and saying, we could be getting a couple of embers. And they could be travelling that far. Like, it's a probabilistic side of things, but that mass spotting side of things, there'd be a good chance you wouldn't be expecting that much spotting to be occurring with a fire.
And is that partly related to the speed at which the fire was moving, and that people on the ground or people within the IMT may not have had an appreciation as to how quickly this fire was moving?
If you're expecting and I suppose we've gone to the line scan on Annexure 3, if you're expecting a more fire line sort of spread of a fire, and particularly looking at Dave Philps' early prediction, his rapid appreciation, that's the sort of prediction you would be looking at. In this situation with this line scan, what you can see is almost simultaneously that whole landscape is alight.
I might just have, for the benefit of those who are watching, I might just have that line scan brought up. It's 1677. Now, this is, some of the evidence has indicated that there may have been spotting across to the southern side of the Bega River by somewhere between 2:45 and 2:50, 3 p.m. at the latest. Now it's now 3:42. In terms of its fire intensity, what can you glean from this particular line scan?
So with the line scan, the brighter the image, the more active burning that's occurring. And so what you can see in the heel or the northwest corner of that fire is it's burnt through the landscape, and you can still see quite a bright edge around that back part of the heel of the fire.
Yes.
But then...
Just so people are following, that's at the top left where the fire has originated from in that Reedy swamp area?
Yes. But the probably the next 80% of that fire that's travelling towards the coast is all glowing and alight. And so it's almost simultaneous that this part of the landscape is all burning. So you've had a fire burning at the heel, it's produced an enormous amount of embers that's just caused a mass flaming and spotting event with that whole front part of the fire there is alight.
And if we assume that the fire may have ignited at around about 12:30, we've got a line scan now and this is the first line scan as I understand it at 3:42. What does that tell you about spread and rate of spread?
Well, it's a very fast rate of spread, and I mean, going back to the model is far exceeding the sort of models, the inputs that we'd be putting in because of that spotting. And the mechanism of fire progression has been, rather than fire line, like the fire burning through the landscape, you've actually ended up with a mass spotting event throwing embers in front of the fire that have all ignited. Spot fires can behave in different ways. In some cases, an ember will land in front of a fire and take a while to build in size. And the small fires don't travel as large as big fires. They need to reach a certain size to hit their maximum rate of spread. So the main parent fire can then overtake the spots and embers. And so they really don't have much of an effect on the rate of spread of fire.
That did not occur.
Not in this situation.
This fire, did it?
Sometimes when you get large pyroconvective fires with enormous convective columns, you can actually end up with draw in front of the fire, and so an ember will land in front of it and burn back towards the parent fire. In this situation, it's different. What you've had is an enormous amount of embers land in front of the fire and have successfully ignited, and they have become the new fire. And so it's beaten anywhere where that fire would have got to if it was progressing under a normal fire line spreading under that wind speed.
And in those circumstances or situations, what, if anything, can be done by way of firefighting strategy? How do you contain or combat such an event?
This is a very dangerous situation because particularly with a normal progressing fire line, a fire is coming at you from one direction. And so you've got a way of dealing with that, even if it's quite intense. Under mass flaming and spotting under these situations, you've got fire at 360 degrees. It's all around you. And so...
And with that, you've got the risk of fire crews being trapped, I take it, between the head fire and then a secondary fire that may commence by reason of the spotting.
You could have fire in front of you, behind you, beside you, everywhere. So that's the danger with these sort of mass spotting events.
Does it really become one of protection of life and property, ultimately, if you're faced with a mass spotting event such as what we see?
Those would be there would be strategies that those on the fire ground and those within the IMT would need to devise under those situations. And I mean, this would have escalated and occurred very quickly. And so people would have had to make decisions under very short time frames under these, in this escalating situation.
Now, there's another... Well, I should ask you this for those who may not know. How is a line scan generated?
So there's a fixed-wing aircraft has a multispectral scanner. So it's a camera that looks at a whole range of different electromagnetic radiation spectrum, and so the aircraft will fly over and take images, aerial images of the ground, and based on so if you look at this image, it doesn't look like a photo. The colours are slightly different to what you would see with the visual bands, because it's based on the spectrum that are used as part of the multispectral scanner as far as what is the optimum for us to get information about the fire intensity.
And that fixed wing aircraft that generates the line scan, where's that deployed from? Is that out of Sydney or somewhere else?
I understand it's mainly from Nowra, the company that we're using at the moment. And I'm not sure on this day where this aircraft, because it may be pre-positioned at other places around the state depending on fire danger ratings.
Yes.
And that's a decision generally through state operations and the state operation controller as to where and when. I mean, the thing to be aware of is, particularly on this day, it had been forecast to be a very challenging fire weather day. and the fire danger ratings were actually, for forecast fire danger ratings, were much higher in other parts of the state. And the Narrabega, Southern Tablelands had much higher forecast fire danger. And as far as priorities and new ignitions, that's a decision that the State Operations Control would be making as far as prioritising that flight path.
Now, we touched upon earlier fire speed. You've done some calculations, I think, since the fire in terms of trying to work out how quickly the fire travelled.
Yes.
Did you come to a point that it may have travelled somewhere between 2 and 3 kilometres per hour?
Yes. Yes.
Now, in terms of comparison to other fires, is that considered a rapid speed?
Yeah, that under those conditions, that exceeds the models we have. It is a very fast, like that's extraordinarily fast fire spread. In the last fire season, we had Long Gully and Busby's. There were the fires in northern New South Wales that were probably travelling between 4 and 9 kilometres an hour. So we have had much faster rates of spread. In 2013, the State Mine Fire did 35 kilometres in an afternoon. So
What about Wombalong?
geez, I tried to draw that one out. I can't recall the rate of spread of Wombalong. You'd think I could, but no, it's just not there on the tip of the mind at the moment. But there are various fires that have had larger rates of spread. But if you look at your normal fires and the thousands that we see, that this is up there as one of the faster fires at greater rates of spread we've seen.
Now, that, as we have heard from you earlier, Doctor, depends on a number of integers: wind speed, relative humidity, temperature, topography, wind direction.
Yep, and vegetation type.
And vegetation type. Now, we're talking here with dry sclerophyll forest.
And wet.
And wet. Was it predominantly dry sclerophyll though?
The mapping I have shows that probably the majority was wet sclerophyll with intermixed with dry.
And in terms of the vegetation calculators or the indices that you would you use wet sclerophyll or would you use dry for this particular exercise?
We'll still use the MacArthur Mark 5, but it's how we modify the MacArthur Mark 5. And one of the things we look at with the modification is a wind reduction factor. So the shorter the vegetation, like fires will travel very fast through grass and heath because there's not as much turbulence or interaction with the vegetation. If you've got tall, wet sclerophyll forest, that has the highest wind reduction factor. So actually where the effect of the canopy will massively reduce the amount of wind that's getting onto the ground and pushing the fire. And so for this sort of vegetation, you would have a very high wind reduction factor, which would result in a lower rate of spread if the fire is travelling on the surface. Once the fire starts crowning and travelling through the canopies, it's a different situation. And generally we negate that wind reduction factor because now the fire's travelling through the crowns.
Now, in terms of other modifications to the MacArthur Mark 5, what, if anything, can be done in relation to fuel load levels?
So fuel load definitely has an effect on the MacArthur model. And the higher the fuel load, the more intense the fire and often the greater the rate of spread. We'll be looking at the fuel structure and particularly how the fuel is arranged. Traditionally you start off looking at surface fuel and leaf litter, but then once the fire is accessing other parts of the biomass, if it's into the near surface or bark or canopy, then you'll be incorporating those other fuel elements into the fire spread model.
And in terms of the area around the Bega Valley, how does the RFS or an individual fire behaviour analyst factor in relative fuel load levels for that particular location? Are they able to do that or
so
not?
By relative?
Well, in terms of, there's the index that has a set load for particular fuel types. But is that for a general area? Or is it more nuanced, more specific in relation to, for example, an area around the Bega Valley?
Yes, we've invested an enormous amount of time in trying to improve our understanding of fuels around the state, which includes the Bega Valley or Bega area. And based on fuel accumulation models, what we will look at is an estimate of what is the fuel load in an area based on time since fire and effectiveness of the last fire as well. And so those fuel models will look at how much litre elevated bark canopy fuel loads we may have, and we've got modelled estimated maps of the landscape that will help with predictions.
And how often are those models updated in terms of those fuel load levels for a specific locale? You would hope it's sort of near time. As soon as a fire goes through an area, we'll be updating models. So we'll be reconsidering and recalculating from the time since the last fire. When you talk of fire, are you also talking of any prescribed burn or hazard reduction?
Yes.
Burns?
Any landscape sort of fire, hazard reduction, prescribed burn or wildfire, will then go into the recalculations for the fuel loads in those areas.
And in terms of fire speed, of all the various integers, are you able to identify of those various integers which are the more important in terms of the effects they may have on fire speed? Or is it like everything goes into the pot and it all sort of has a bearing ultimately?
And again, I'm trying to work out how to summarise this. There's a complex answer to that. Fires actually, I suppose you could think fires transition through various sort of stages as far as they evolve from a small fire that's not very intense as opposed to a massive eruptive fire like this. For smaller fires, fuel loads are very important. It's probably the principal thing that affects that fire and fire behaviour. As fires escalate, landscape becomes more important, and then ultimately weather becomes the most dominant thing. And under the worst conditions, it's generally the weather that's driving the fire behaviour more than the fuel. And I suppose it's the relative influence. Fuel still has an influence, but you would say under the more extreme fire behaviour conditions, relatively it's more the weather that's driving what's happening with that fire.
In relation to the Tathra fire or the Reedy Swamp fire, do you think fuel load levels would have had any bearing on the ultimate outcome in terms of how this fire behaved and how fast it spread?
It would depend on where and when that fuel modification had occurred, and so if it was somewhere near the origin, it could take fires, particularly lower fuel loads during the build-up phase, can take fires longer to initiate. Once that fire had built up a head of steam and started producing that spotting, the effect of any fuel modification would be a lot less. And particularly in this last fire season, we had areas that had burnt, and then a couple of months later, fires came through and burnt the same area again. and so if you get once a fire's up and running, particularly under more extreme weather conditions, there is a much lower effect. At night, yes. In the initiation stages, yes, but it wouldn't be as noticeable. And particularly because you were getting this mass spotting, you would have to have the entire landscape reduced to have an actual effect, and it would have to be very recent as well.
Yes, thank you. Now, we might go to the second line scan, which I think is the next page. Dr. Heemstra. Now, again, this one's taken at 4:11. What do you interpret from this particular line scan?
So we're half an hour later, so it's not that much time difference since the last fire, and you can start to see that there's more pressure on the northerly edge of that fire. There's a lot more intensity on the northern side, but also the fire has continued to now spread into, you can see streets and suburbs where that fire is moving into. You can also, so the fire is larger and more intense, but also you're starting to see, particularly on that the right-hand side of the eastern edge of the fire, there's quite a lot of smaller spot fires you can see in amongst the streets as well.
Yes. And then the next one over the page, 1679, is at 5:42, so it's an hour and a half later. And what do you see in that line scan of any significance?
The fire's run out of things to burn on the eastern side, so it's reached the coast.
By the case, we can see it there.
You can see the fire has pretty well impacted and burnt through a lot of the township. So now the whole eastern or the right-hand side of that image, you can see a lot of fire in that part of the landscape.
On that eastern edge, that's likely to be structures on fire?
At this resolution and scale, it's hard to tell. You'd need to zoom in. It is likely that, I mean, there were close on 100 structures probably being impacted and burning over that time. So,
and just tell me if you agree with this, but just looking at that line scan now, are we looking in terms of an area of somewhere in the order of 1,200 hectares?
yes, I mean, ultimately, I think we reached 1,300 hectares with this fire. So yeah, it'd be close. It'd be close to that size by that stage, yes.
Now, shortly after this period of time, at around 6 p.m, there was a wind change, was there not?
Yes.
And we saw the winds move more to a sort of southeasterly direction. What, if any, effects did that have on the fire's behaviour?
Well, what we were quite concerned about was that the whole flank was going to then push north, and.
When you talk north, are we talking that area north of the river or that area north of the township?
North of that whole area, like that whole fire line could have pushed quite significantly north. But what happened with the wind change is that it actually wasn't that strong a wind change. We were fortunate for this fire that the wind change was quite weak that came through. Wind speeds, which we were seeing 30, 40 kilometre-hour wind speeds by the time the wind change occurred, and I'm referring to the Annexure 10 as far as the wind speeds we were seeing, that they were in the order of the teens and 10 kilometre an hour. So we didn't have that significant a push to the north of the fire.
And then at around about this time, early evening, was there a change in the moisture lag?
Yes.
So you referred to at the start of your evidence this morning. What happened in terms of that fuel moisture lag?
So what would happen traditionally with a southerly wind change? It's coming across the coast. There's a lot more humidity in that air, so it becomes more humid in the air. But particularly because that's a rapid drop in or rapid rise in humidity, it takes a few hours for the fuels to see that. So one of the concerns we've often got is if you get a very strong wind change, it can be very dangerous because your fire front, what was quite narrow, small, heading towards the coast, now becomes that whole line of fire to the north. And if that is a strong wind change, the fuels stay dry for a few hours, and so you can have a couple of hours of very dangerous conditions where that fire can take a major run to the north. And we've had quite historically within Australia some very damaging and fatal fires that have done those sort of things. And the other thing probably is it's often challenging to predict the exact nature of a wind change. Sometimes they come inland and sometimes they stay out to sea. And so there's often uncertainty as far as how strong a wind change is going to be. And in this case, it wasn't that strong a wind change.
And that was good news.
Yes.
Now, in terms of the fuel moisture content, relative humidity comes up. That means there's more moisture in the air. Is that because that southeasterly has come across the coast, across the ocean? But then the effects of that, as you said, could take somewhere between 2 and 3 hours for that to have a bearing on the fuel load.
Yes.
Now, you mentioned that you thought it was in the sort of the 300s in terms of fire extent. Can I take you to 1685? If that could be brought up, please.
Yes.
Now, that is a map, is it not, of the final fire extent?
Yes.
And I think in your evidence you've said that it encompassed an area of 1,395 hectares. And that map was done when the fire was declared extinguished.
Yes.
Now, that's a relatively large area given the time that has elapsed between ignition, 12:30 or thereabouts on the 18th of March, until it was formally declared extinguished a few days later. Now, given, again, what you know based on your analysis, do you think anything could have reasonably been done in relation to this fire in terms of suppression, or not, given this mass spotting event to which you've referred?
It depends on the time to which you can get there. There's generally a small window on those sort of days. If you're lucky enough and have good enough access, you can get to a fire and put it out. And if you actually look around the state on that day, we had a lot of fires.
Well, it depends on the material, but it's certainly somewhere between 18 and 22 that I've read.
Yes.
In and around that area.
And
some are obviously more significant than others. Obviously, Frogs Hollows and Kerrison's Lane were priority fires, but nonetheless there was a number of fires occurring in and around that bigger area.
So some fires we're lucky enough and the access is good enough, or we're close enough and you can get to them in time. And others, like this one, if you're not able to get there before a fire develops, you can struggle. Now, particularly because if you have a fire starting under very strong winds on a steep slope, access, and I'm not completely familiar with the point of origin of where this fire is, and so I'm just general principles. But if access is difficult, once that fire gets up a head of steam, it's very difficult to do anything with it. And particularly if a fire is then able to hit that ridgetop and start throwing embers, it's just about impossible. Like you've really you've now got a landscape on fire.
And that's because you, as you alluded to earlier, you're in effect getting secondary runs of fire because of the spotting effect, and they then become the new fire front.
Yeah, and even it then comes down to decisions as far as strategies of management with the fire that you need to make in very short amounts of time under this situation, because you look at how quickly this fire spread. Within 2 or 3 hours, you had the whole landscape on fire.
I think it travelled somewhere in the order of about 6 kilometres, did it not, from its point of origin?
Yes.
In that period of time?
Yes. And that's a lot of landscape to cover, and particularly if you've got rugged terrain and difficult access fire trails, and it can be quite a dangerous situation.
And busy fire crews here, there, and everywhere attending to other fires.
And that's the other thing that's important to contextualise, is that there was bad weather everywhere, and that you've got to be prepared for a fire anywhere in the landscape as well.
Now, if we exclude the most recent bushfire season, given your understanding of what occurred in relation to the Reedy Swamp fire, and in particular that mass spotting event for which we've been discussing, how does this fire compare to other fires in relation to mass spotting events?
This is a significant mass spotting event, and I think we spoke earlier this morning. This is a case study that we'll be using as far as understanding fire behaviour and some of those phenomena that it helps highlight for us the sort of things you can see. And it definitely, this is a significant fire in Australia's history as far as fire behaviour and fire impacts.
And fire speed.
Fire speed. And we have sort of been eclipsed over the 1920 season as far as impacts and losses, but prior to that, this is a very significant fire.
And some of those lessons or takeouts centred around some of that high resolution simulation modelling that has been undertaken by the Bureau of Meteorology?
For the weather modelling, yes, definitely. It helps us, and we've had this with a few other fires in Australia's history around the country where we've done that high resolution understanding, and it helps build the science and understanding for future prediction. And this will give us some flags or things to think about in future that we've learnt from this event to help us better predict these sort of things in the future. Apart
from that deep analysis in relation to the effects of weather and the mountain waves and the rolling, or the boundary rolling layers, what other scope is there to interrogate at least the Vesta or the MacArthur Mark V model to build into that a capability to aid in the prediction of mass spotting events?
I think that it helps us better understand the sort of inputs and assumptions that we'd be using with applying these models. And it also helps us probably contextualise the discussion that the fire behaviour analysts might be having with the incident management team as to the effects of spotting. And spotting has been one of the very challenging parts of fire behaviour because of its stochastic nature. And there are so many times we predict spotting, and it could be going over a road or a river or a dam or whatever, and the spot never gets there, so it never happens. So it's sort of, but I think it's still, from a worst case scenario, it's something that we need to, be having a better appreciation ready in our back pocket, those sort of situations where you get those. And I think you said later we're going to talk about the different products we've got with fire behaviour analysis.
That's where I was going to end, so now's an opportune time.
Okay.
I'll throw it to you,
yes.
Doctor.
So, I mean, one of the challenges is how much time it takes to give a useful product to make decisions and help with what our fire behaviour analysts do. And so in the first instance, generally a fire behaviour analyst will do a thing called a rapid appreciation. Colloquially, sometimes it's called a quick and dirty. And there's very few assumptions in it. It's just pure raw model output. It gives you an idea, generally the fire's going in this direction, but it's something we get out really quickly to give a product to the IMT to say, here's generally the potential over the next few hours where this fire could go. Other products we look at that can take 1 to 3 hours is a best estimate or a worst case scenario. And so that's looking at things like wind reduction factor, working with our embedded meteorologists as far as what are we seeing with the observations of the weather, how's it different to the forecast, so modifying that weather stream, looking at observations as far as fire behaviour that we're seeing. And so the best estimate and the worst case take time to produce, and I think that's one of the challenging things with fires like this, is that it was done and dusted so quickly.
Well, I mean, when it's moving perhaps 8 to 9 kilometres per hour,
yeah,
you don't have a lot of time in terms of a window to work within, do you?
So and I mean, another product we've also got available is computer spread simulation, and so that's just based on how the things have been set up and what are the input variables into it. It still gives us a good indication. And I see in the future for fire behaviour analysis, what we're going to need to produce is more sophisticated computer simulation that puts in ensembles of weather and fuel types and gives us a range of probabilities as far as fire spread. And hopefully we'll be able to produce those a lot quicker, and it will eventually complement and then possibly overtake what we're doing with the manual analysis, because it takes so long to do these. And fire behaviour analysis it's an evolving and developing science, and it's something we've only really been doing progressively over the last decade, and there's still a lot of opportunity for improvement into the future. And I think particularly one of the lessons from this fire is making sure we incorporate that worst case scenario, and having that there where we've got the capacity, because the other thing with this one also was there were so many fires around the state. There was predictions being done for a whole lot of other areas as well, and this had a prediction. There's some fires that didn't get them, so it's something that possibly with better automation and computer simulation modelling, we'll be able to make sure that everything gets predictions and use that probabilistic, that ensemble sort of forecasting, have worst case scenarios with weathers and fuels and those sort of things. That'll give us better products into the future.
And would that include line scan input into a computerised program?
Yes, yeah. There is a possibility, and this is not a short-term thing, but you could potentially have a model that you feed with the range of uncertainty with weather and fuels and other phenomena. It then, once a line scan's been run, you could use artificial intelligence to actually, what is the subset of the input parameters that we could have used, and give you a better estimate into the future. And so with that more rapid turnaround, that could help us. It definitely improved timing and resolution of line scans will definitely help, the accuracy, the iterative accuracy you get during the progression of the fire.
Which means an earlier line scan.
Definitely.
In terms of the computer modelling that's presently being used, is the main one Rapid Fire, Phoenix Rapid Fire, or not?
Operationally within New South Wales, yes. No, there are a range of models being used around Australia, but currently that's the one. And for this fire, this time, that was the one that was available.
And is that the one that Dr. Matthews would have utilised when he came to do his predictions?
Yes.
Does the fire behaviour analyst who's embedded in the IMT at a local level have access to a Phoenix Rapid Fire simulation or not? Or is it only within state operations?
They do now. I'm just trying to think back to 2 years ago whether we had it. We've been building a range of new products as we go. Generally, the way we work as far as fire spread prediction, within the IMT, you're very time poor, and there's a lot of fires and a lot of activity going on. What we found is that often, and particularly over this last fire season, we'll have a team of people within head office, and they're good for initial fire starts and also supporting the F-bands within the IMT by doing predictions. What we do is that we'll have computer simulators and manual analysts, and there's a brick wall, an imaginary brick wall between them. I don't like the manual analyst seeing the computer simulation because, and even myself as a fire behaviour analyst, once you've seen it, it biases you. And so if it's a good, at the moment, the fire spread simulation models are, the computer ones are good triage tools, and they give us an indication of the spread. But generally, 9 times out of 10, at the moment, my manual analysts are still beating the computer. And so if they have time for a best estimate or worst case scenario, like to do that analysis, make the assumptions, look at fire behaviour, it's still going to beat the computer currently.
Thank you, Dr. Heemstra.
Thank you.
Mr. Cheney. Mr. Smythe, do you have any questions?
No questions from me, Your Honour, thank you.
Mr. Goodman, do you have any questions?
No, thank you, Your Honour.
Mr. Lloyd?
No, Your Honour.
Mr. Baroni?
No, Your Honour.
Right. Mr. Newton?
Dr. Heemstra, you
were asked some questions about, you gave some evidence that, as far as your mapping was concerned, that there was wet sclerophyll and dry sclerophyll forest in the area that was impacted by this fire. Now, just dealing with the, perhaps if we can go to the line scan, the first line scan, which is at page 1677 of the brief and annexure 3 to your statement.
Yes, on that.
Just if you can see from, say, the area which you've described as the heel of the fire in that north-east corner through to the Bega River, do you understand what I mean, just generally by that area? Is it your understanding that in that area there's a mix of wet and dry sclerophyll forest?
Yes. Yeah.
And that proportionately there may in fact be slightly more wet sclerophyll forest in that area than dry sclerophyll forest?
The mapping that I've seen has, mainly that. I'd say it would be the gullies. It would be have more of the wet sclerophyll forest. Then on the ridgetops would be more of the dry, but over half of it appears to be wet sclerophyll from the mapping I've seen.
And if I understand your evidence, a characteristic of wet sclerophyll forest is that fires, at least in their initial stages, can burn more slowly in wet sclerophyll forests. Is that correct?
Yes. If you've got taller forest with a denser canopy, you're not going to get as much wind onto the fire, onto the surface that you do in a more open sort of situation. So the initiation development phase under those sort of conditions can take longer.
And that may be one reason why a fire behaviour analyst might. Well, actually, I would draw that, Your Honour. As it turned out, you've described, Her Honour, that there was a mass spotting event in this fire. And is it reflecting on this fire with the benefit of the hindsight and your knowledge of that more fine or granular approach to the weather that you've described, the wet sclerophyll forest aspect of it is something which probably contributed to the mass spotting event. Is that correct?
Yes. If you've got more material that can break away from the fire and produce burning embers, you're going to get more spotting. And if you've particularly wet sclerophyll forests often will have more ribbony bark, and particularly that bark fuel is quite a predominant thing that will help with that sort of long range spotting.
You mentioned that you used a term in your evidence, normal fires, or something to that effect, and at one point you said we get thousands of normal fires. You recall that evidence?
Yes.
Now, is this correct? Even on a day of high forest fire danger index, there'll be normal fires on that. You can have normal fires even with a high FFDI, is that correct?
Yeah, I suppose I need to characterise what I'm saying by normal. I'm looking at what generally we teach and understand is a traditional fire progressing over a fire line, and so it's a line of fire burning in front of itself. Where you get the more eruptive or explosive fire behaviour, those are more rare events, and this is an example of one of those more rare mass spotting events.
And they're more difficult to predict. Is that right?
Definitely, yes.
And it's often easy. I'll draw that. It's much easier with the benefit of hindsight and seeing an event erupt than given an explanation than it is to try and predict it before it actually occurs.
It definitely is. And it's a thing that we're learning as time goes by, and we're actually, over time, we're seeing more of these sort of events occurring. Pyroconvective fire behaviour, we've already noticed that's almost increasing exponentially over the last couple of decades, that we're seeing these sort of events occurring. that's the thing that's linked with instability. In this case, it was more the local situation, and I would say because of a lot of the wet sclerophyll forest, but also because of those micro weather phenomena, that it led to this sort of a spotting event. And I think in the future, there are probably flags that we could have considering that sort of vegetation type. Under those situations, we need to be looking at those as our worst case scenario.
In that kind of topography close to the coast.
Yes, definitely. And there was a fire in Roleystone in Western Australia, and we also had the Kangaroo Island. There were other examples where you've had those sort of ramps that have helped escalate fire behaviour, and it's probably flags for us to think about. We've got other phenomena. Professor Sharples from University of New South Wales looked at vorticity-driven lateral spread, and so there's certain situations where you'll get topography lining up at 90 degrees to the wind direction, and so that you might get that sort of eruptive fire behaviour. The lee slope eddies, so there's a whole lot of other phenomena that we're building our understanding over time that probably we've just never focused so much now before, and now we're building this knowledge as we go, and this is one of the ones that will help us with building that knowledge.
Well, you mentioned Mr. Sharple's research. You actually gave some evidence in relation to the Wombalong fire on where there was that phenomenon of the vorticity-driven lateral spread. That the Wombalong fire was an example of a fire which there was extreme fire behaviour which wasn't predicted, and under the then models wasn't able to be predicted. Is that correct?
Yes.
And another matter, another phenomenon which you've touched upon is the pyroconvective fires, and you've talked about there's an exponential increase of that in recent years. Again, that's a very complex matter which you're developing tools to predict, but at least over the last decade it's been extremely difficult to predict which fires of the many that start in a landscape that is going to happen to. Is that right?
Yes, and we have over 30 portable automatic weather stations that we now deploy to firegrounds to try and get that better local intelligence. We deploy weather balloons now to understand our atmospheric stability, and the only fire service I'm aware of that actually does that in the world. So we put a lot of effort into understanding and building our knowledge into these sort of fire behaviour. In this case, it wasn't a pyroconvective fire. So it wasn't that sort of a mass flame. This was another sort of phenomenon, but yeah.
But it's another sort of phenomenon that is extremely difficult to predict. Would you agree with that?
Yes.
And another fire in similar landscape, under similar conditions, may not, in fact, have a mass spotting event.
Yes.
Right?
Yeah, definitely. You could. Yeah, you could have just a normal fire line progression. It depends how similar the situation is. If it's the same, well, then you're going to get spotting, that sort of spotting. But further up or down the coast, you might not have had that much of an effect of the mountain waves, the boundary rolls, and those sort of other things. You might not have had the ramp and the uphill spread. So there could have been other parts in the landscape where, and there were fires that were more containable and suppressible. But this was just a nasty spot to be. It was the perfect place to start a fire that you're not going to be able to get on top of.
Well, when you talk about the ramp, that's something which presumably is a very specific characteristic. So you have a wind from a certain direction and topography, and it's the interaction of the wind from that direction, a particular aspect of the topography and the vegetation on that which leads to the ramp. Is that right?
Yes, yeah.
So, for example, if the topography is in a slightly different, if the slope of the hill is going in a slightly different direction, you may not get that ramp effect.
Yes.
And you spoke about that there are the mass flaming or spotting event, which was revealed by that by the first line scan, where you talk about the whole of the landscape being on fire, or a lot of the landscape being on fire. That's something which the impact of that mass spotting event into a village like Tathra makes firefighting an extremely difficult proposition, does it not?
Definitely. And rather than looking at the fire, it's coming from this direction. You've got to be looking over your shoulder and everywhere around you, because you've got spots occurring all over the place. So it actually makes it very challenging, because the fire is all around you rather than just coming from one direction.
And that explains why, for example, houses maybe 1 or 2 streets back from the forest were impacted by this fire.
Definitely. I mean, it's going to depend on the property maintenance, and I mean, particularly if you're looking at structures igniting as a result of spotting, there's either going to be weaknesses within the structure that enable the embers to get into the structure, or there may be maintenance issues or combustible material around the structure. And so if you've got that sort of mass spotting occurring within a suburban landscape, there's going to be all these opportunities for fire to start from the spotting that is actually not related to the fire progression of the fire front. And it's going to depend on that construction standard and maintenance of the property as to the probability of ignition.
And when you've got mass spotting, then obviously the probability of ignition increases greatly in the suburban area that you're describing.
Definitely, yes.
And the probability of suppressing it decreases as well, just because there's fire igniting all around the landscape. Is that right?
And you've got limited resources and how many structures are on fire, so that becomes a challenge.
In terms of the, you gave some evidence that there are so many times when we predict spotting and it doesn't happen, or something to that effect. So that's another complexity in terms of fire behaviour analysis, and also the use that an IMT may put on a fire behaviour analysis. Would you agree with that?
Yes, and I mean, generally the smaller, lighter embers are going to travel further, but if you've got uplift and more turbulent wind, it's going to pick up bigger material and travel, and that's going to travel further. So the more heat there is in that material that lands, the more likely it's going to start a fire. Then it depends on how combustible what it lands in is. So how dry is what the material that's landed in. A small ember will ignite something very, very dry, where if it's got some moisture in it, it won't. But a large ember could obviously get something to burn that's not as dry.
And in terms of firefighting, given how difficult it is to predict, say, firstly, where a spot fire may commence, and secondly, whether or not the spot is going to actually start a new fire, then really the only practical way to combat that is to send resources to a spot if and when it occurs. Is that right?
Send it to an area rather than a spot. Yeah, so that you'd be looking within this area. You'd need to be considering, but how to know where that ember's going to land to be successful, it's completely stochastic.
And finally, Dr. Teamster, today's your last day with the Rural Fire Service, is that right?
Yes, it is.
And tomorrow you're starting at the Bureau of Meteorology, and is that correct?
I do, yes. There's a good way to finish my time with the Rural Fire Service.
So I just want to thank Dr. Heemstra for extending his time with the RFS for a extra week, I think, Your Honour, if not more, to give this evidence today.
And are you going to continue as a volunteer?
I will, yes, Your Honour.
Put that in writing. Well, congratulations on the change of path, and thank you for your evidence and your service, Doctor. I mean, that. Oh, did you want to ask me?
No, I did not.
I didn't think so. You're now excused.
Thank you.
I see the timer.
Yes. We'll adjourn for morning tea. Thank you. Yes, Mr.
Your Honour, I call Nienke Van Dorn, who's in Bega.
Ms. Vendor,
Yes,
do you solemnly and sincerely declare and affirm the evidence that you shall give me the truth, the whole truth, nothing but the truth? If so, please say I do.
I do.
Ms Van Dorn, can you see and hear me?
I can.
Excellent. Do you live, or did you live at the time of the 18th of March 2018 at 143 Thompson Drive?
Yes, I did.
Can I ask that a document be shown on the screen, page 3066 of the brief? It's from volume 8, tab 94. Ms Van Dorn, I'm asking for something to be brought up on the screen. Can you
Okay,
see that document on the screen in front of you?
I can.
Are you able to tell from that document where, roughly, along Thompson Drive your residence is?
No, because it's a bit fuzzy. But if you go along the Bega River, go along the Bega River to Lake Cohen. It's the two headlands into the river and Lake Cohen, where Lake Cohen and the river meet.
Right.
About there.
Can I ask that it be zoomed in just a little bit along Thompson Drive and see if that helps you at all? Can you see, for example, up the top, a reference to a humbug reach?
Oh, never heard of that. But yes, I can.
Where is your premises relative to that? Is it further to the south?
It's further to the west. You can see the little green dot with the little, that's getting close to it. That's my residence there.
That green dot that the cursor is over now?
Yes, that's it.
On the left-hand side of the image towards the centre?
Yes.
Thank you.
What's the letter in that word?
Is the letter P in the word Thompson?
Can't see that, I'm sorry.
If I just
Where's
ask that to be
Thompson's
zoomed
Drive?
in one more time.
That's Thompson's Drive there, and that would be my residence there.
Roughly where that green dot is.
Yeah.
Thank you, Ms Van Dorn. Now, were you in Tathra as at the 18th of March 2018?
Yes, I was.
And how did you become aware of the fire that day?
I saw flames consuming my carport.
And what time was that?
Approximately 3:10.
And where were you at the time you saw those flames consuming your carport?
In my house,
And
sitting on the lounge.
on noticing that, what did you do, Ms Van Dorn?
Ran
Where did you run?
towards the carport. My car was in the carport. My husband's car was on the driveway. One of the dogs followed me and he picked up the other. I put the dog in the back of my car, threw my handbag on the seat, put the key in the ignition, realised that there were flames on both sides of me, in front of me and over my head, and lapping at the wheels of the car. I jumped out of the car. I left my handbag behind. I opened the back door to let the Great Dane out. We ran to my husband's car, jumped in it and drove through flames along our driveway. At the top of my driveway, I looked back. My house was already in flames. We drove through flames for about 300 odd metres, and on Thompson's Drive, and drove to the fire station and somebody came out of the fire station, her name was Prue, and said, "Can I help you?" I said, "My house has just burnt down." And she asked, "Where do you live?" I said, "Thompson's Drive," and the fire has jumped Thompson's Drive and is heading to Tathra.
Yes. Are you able to say what time it was by the time you drove away from your residence?
Yes, I can. It was about 15 minutes, maybe 18 minutes past 3, and I would have been at the fire station before 25 past 3.
And which fire station was this, are you able to say?
Yes, that's Tathra Rural Fire Service, which is on the western side of the town.
Yes. Is that to the south of your residence?
Yeah, roughly southeast the residence as the crow flies.
Yes. And having had that conversation with the person at the Rural Fire Service station, what did they do?
She said, swore, and said, "Oh my God, it's jumped the river," and ran towards the fire station.
Right. Now, prior to you leaving your house, did you have any contact with anyone from the Rural Fire Service or any emergency services personnel?
Not on that day, no.
Did you at any stage during the course of that afternoon receive an emergency warning of any kind?
No.
Now, Ms Van Dorn, I understand that you'd taken some steps to try and protect your house from fire, is that right?
Yes.
And what were those steps?
Okay, we had 2 dedicated tanks of water. We had a firefighting pump with a hose attached. We had an underground line to the roof of the house with a sprinkler system on the house. At about 1:30 that day, I started to get worried, so I enacted my fire plan. I turned the water so that it would go up to the sprinklers. We primed the firefighting pump. We got everything ready, and I changed my clothes to be more appropriate for in case there was a fire. Put shoes on. Put a grab box on my dining table to take with me. My handbag with some treasures in it. But at that stage, there had been no warning. The electricity had gone off. We had pulled out the emergency battery-operated radio and a battery-operated torch, and were listening to them with a pack of spare batteries on the coffee table in the lounge room, waiting for a warning. And the last I heard, which was around 3 o'clock, that the fire was a good 15 kilometres from me and there was no need to worry.
And how did you hear that at about 3 o'clock?
I think it was while I was flipping around the radio stations. The ABC, which is our emergency station, didn't have anything except the football on, telling me what a lovely day it was for football. And I flipped around to one of the local channels and I heard that information. And I think I even had a joke with my husband about them.
Yes. You said that you enacted your fire plan at about 1:30 that afternoon. Why did you
That's
do that?
right.
Sorry, why did you do that, Ms Van Dorn?
I did that because of the high temperature, because of the wind, because we were dry. Everything was so dry and crackly. And I just had the smoke and it was getting bigger, and it was getting more orange, and it was getting thicker. So I thought, just enact it, and better be safe than sorry.
So you could by that time see smoke,
Oh yes,
and did it appear to get or be getting bigger
oh yes.
and coming towards you?
Well, I didn't know where it was going. It was still a fair distance away from me on the horizon towards the, I'd say, northwest.
Yes.
But there was an orange glow, and when I see that dreadful orange glow, it indicates to me that there's a bad fire going on.
And were you ultimately able to leave Tathra that day?
Yes, late afternoon we left Tathra from the fire station. I went to warn a friend of mine, and then we went to the surf club, and we ended up sitting in the water at the surf club with wet towels over our heads that we'd taken from the surf club in the surf with the animals. And at some stage there was an order on a megaphone from the police, because there was no other form of communication, saying to head towards Bermagui, and then a couple of minutes later, don't go that way, the road is closed, stay in place, and then go to Bega, no, stay in place. And this happened a few times, and finally they said, we're going to lead you out to an evacuation centre at Bega Showground about 4:30, 5 o'clock in the afternoon.
Yes. And were you ultimately led to that evacuation point?
Yes,
And Ms Van Dorn, you lost your house, did you?
I lost everything except the clothes I stood up in. I lost my car, my handbag. The only thing that we got out was the 2 dogs, my husband's car, and he had his garden shoes on, tracksuit pants, no underwear, no socks, and a shirt in his hand. And that was it. That was the sum total of our possessions.
Ms Van Dorn, I'm very grateful for your time today, and I'm very sorry for what you went through. I have no further questions for you.
Thank you, but it's okay.
Have you rebuilt?
We're in the process of rebuilding now.
Oh, it's still in the process.
Well, it took 14 months to get it through council, and ever since then we've had 3 floods in the last 6 weeks, the fire in New Year, equipment that you couldn't get in, tradies that kept going off from October to fight a new fire somewhere or other with their equipment. But we're nearly there.
Right. I think your house was the first one to be ignited.
Yes, it was.
Mr. Smythe, do you have any questions?
No questions, Your Honour.
Right. Does anybody else have any questions?
No, Your Honour.
No. Thank you. Thank you for your time and your input to the inquiry, and thank you for your resilience.
Oh, thank you very much.
All right. Thank you. You're now excused.
I'll call Deborah May.
What tab number is this?
I think it's behind 82. I'm not sure which individual. Just let me check that, Your Honour.
Oh,
His nave is number 46, but
Yes.
82. Yes. It's page
Before the court, Your Honour.
Ms. Nave, do you want to give an oath on affirmation to tell the truth?
An affirmation, thank you.
Do you solemnly and sincerely declare and affirm the evidence that you shall give with the truth, the whole truth, nothing but the truth? If so, please say I do.
Yes, I do.
Ms. Nave, can you see and hear me? If I wave my hand,
Yep.
does that assist?
Oh, yes, there you are. Yes. Hello.
Thank you, Ms. Nave. As at the 18th of March 2018, were you a resident of Tathra?
Yes, that's correct.
And where did you live?
At 17 Bayview Drive in Tathra.
Yes. If I could show you a document on the screen, this is page 3066 of the brief again. And if I could get that zoomed in on the right-hand side of the page. Can you see the location of your address, Ms. Nave?
Yep, I can see Bayview Drive there. Yep.
Yes. Is that where the cursor is located at the moment?
Yes, that's right. Yep.
And roughly on that street, where was your premises located?
Oh, well, where you've got the green marks, that's pretty much.
Yes. So in that area?
Yeah, in that area there, that's correct.
Yes, thank you, Ms. Nave. If we could take that off the screen, thank you. Now, as at, I withdraw that, you were in Tathra on the 18th of March, Ms. Nave?
Yes, yes.
And what time that day did you become aware of the fire?
Oh, look, yeah, so when I say I was in Tathra, I was not in Tathra in the morning. I returned, I'm not really sure, I don't really want to talk times, but I'd been performing at the Multicultural Festival in Cooma, and I'd left there around midday and came back home. So probably arrived home around 2. But I could see the fire on the way through, and then had looked at it from Thompson's, and then had seen that it was across the other side of the river from that Thompson's in Tathra, and then I had made it home. So probably I was home from around 2 o'clock. So I was, but I was talking with my partner on the way down from Cooma back home. So I knew that there was a fire happening,
Did you know there was a fire happening because you saw smoke or for some other reason?
Yeah, because I'd seen the smoke after driving down Brown Mountain, and then seeing the actual fire across the river from Thompson's when I drove there, and then from home. But like we could see that there was smoke for sure, and big winds.
Yes. And what happened from about 2 p.m. onwards after you returned home?
Yeah, so a lot of our neighbours were sort of out on the street, just going, well, what's going on? We hadn't heard anything. It was a bit tricky though because there was no power, and we didn't have. We had very poor mobile reception up there. Yeah. So anyway, my kids actually were in the pool, the neighbour's pool. So I was like, come on, let's get them out of the pool. But at that stage, none of us thought it was coming towards Tathra. If anything, we thought it was heading, towards Tanger. Yep.
When did you?
And we knew it was the other side of the river. So. Yep.
And when did you become aware that it was heading towards Tathra?
Look, literally just seeing it seeing the bush on fire up the back.
When you say
And-
the bush on fire up the back, do you mean on the
Yeah, sorry. So from our house, we could see, our house is 3 rows of houses in from the bush,
Yep.
but the bush was on fire behind, where we can see up to the bush from our house. Sorry, it's a bit vague, but we could see that it was on fire, and then we just pretty much got out. We just got into the car and left. But I mean, just to show you how unaware we were that it was actually coming towards Tathra, was, you know, we did grab passports and a computer, but we didn't take anything else with us. Like, we weren't actually thinking our house was going to burn down. We didn't, you know, we hadn't even, like, my partner hadn't even packed anything during the day. So we really didn't know that, you know, I mean, in hindsight, we should have known, but we didn't. We should have known because of that strong wind, but we didn't think it was coming our way anyway.
Yes. And so roughly what time did you leave your house?
Oh, look, I'm not going to say times. I didn't say times on my statement because it's all, I really don't know.
Appreciate that. What did you do after you left the house?
Yep, so we just went, so we were talking, you know, myself, my partner, we've got 2 boys and our dog. We headed down to Mogarika because on the driving down Bayview, someone just yelled out, one of the neighbours, everyone's meeting at Mogarika. But, you know, later on I heard there were people, they met at the surf club. So we were down there. And then once we got down to Mogarika, then I did get a message on my phone saying that we should leave. I'm assuming that was through the fire, the RFS, but I can't remember exactly. But we didn't get a message to evacuate until we were down at Mogarika anyway.
Yes. When you first noticed the fire in the bush, did you see any Rural Fire Service or Fire and Rescue New South Wales trucks in the vicinity?
No.
And did you see any such trucks by the time you left your premises?
No, we didn't see any. No.
Or on the way to Mogarika?
No, none. And I didn't see any at Mogarika either. No.
Yes. And so you say you received a text message at some point when you were in Mogarika.
Yep.
Did you receive any other messages or warnings during the course of the afternoon?
No, there was nothing, but, you know, I think part of that is that we don't have good mobile. We didn't have good mobile reception at the time, so possibly it was sent through earlier, but we didn't receive it because, you know, to send a text message, for instance, we had to go out onto our out to the front of our house or walk up the road. So, and quite often we couldn't even send a text message. So that's, you know, for a message to get through would have been pretty impossible. Yep.
And what happened to your home, Ms. Nave?
Oh, yep. So it was burnt down, totally destroyed.
And when did you find that out for the first time?
It wasn't until 11 p.m. that night when because we'd made our way to Bermagui when we were told to leave at Mogarika, and then from there we went and stayed with friends in Brogo. Anyway, yeah, we had someone who had stayed in Tathra to defend their house, who had driven around the streets and seen that ours had been destroyed. So we found out that night around 11 p.m.
But you didn't find out
Yep.
exactly when your house was destroyed? They didn't tell you when exactly your house was destroyed?
No. But looking at where that bush was and that wind, I think it would have been pretty soon after we left. But again, sorry, I'm being vague because I'm not telling you a time. I just haven't. Yeah, it's all. Yeah.
No, I can understand why you can't put precise times on things, and I'm not asking you to do so, Ms. Nave. Have you been able to, in the period since the fire, rebuild your premises?
Oh, no, we're actually trying to sell. We're selling our block. Yeah. We're hoping to build somewhere else. Yeah. So we're renting at the moment nearby.
So you're renting in Tathra or somewhere around?
Yeah, we're renting in Tanger, which is about 10 minutes away from Tathra. Yeah.
Yes. Thank you very much for your time, Ms. Knight.
Yep, no problem.
I'm very
Okay.
sorry that you lost your house and went through that.
Yeah. Yep. All good. Okay, thank you.
Just a moment, Mr Smythe, do you have any questions?
No, thank you, Your Honour, no question.
Does anybody have any questions?
No, Your Honour.
Ms Nave, good luck with the sale and the rebuild. Well, we're
Yep, thank you.
buy again. All right, thank you, ma'am. You're now excused.
Thanks so much. Bye.
Those are the witnesses for
You quick. Okay.
All right.
That concludes the evidence today, Your Honour. Tomorrow at 10 o'clock, I understand we have Professor Blackburn and Dr Russell, the electrical engineers, who will be giving their evidence concurrently. And then at the conclusion of their evidence, Mr Jeff Conway.
Thank you. Right.
I think that's cobalt. Oh, are you calling him later? Are you calling him later?
I'll take up whatever's occurring behind me
Sorry, Your Honour, I didn't.
at a later time. But that concludes the evidence today.
All right, thank you. We'll adjourn till 10 o'clock tomorrow. Thank you.